Okay, guys, open your notebook to page 68. We're going to label at 8.3, medians and altitudes of triangles. We're going to do page 68 today and 9 tomorrow. Okay, I'm going to go ahead and label 69 the same thing. There's a foldable that goes along with this video. But of course, if you don't have a printer, you just take a white piece of paper, fold it in half, and make one. All right, today and tomorrow are the last two triangle centers, okay? Then we're going to do a triangle centers review for a little while. All right, so here's the foldable that you're looking for. We're going to talk about this triangle center. All right, so today's is, first of all, let's talk about a median. A median, which was in your vocabulary words, of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. The intersection of the three medians is the centroid. That is the triangle center we're talking about today. And here's the theorem. The centroid theorem states that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So AP, here's P right here. AP is 2/3 of the whole piece, which by the way means PX is 1/3. Okay. BP, this piece, is 2/3 of the whole thing, BY. And CP, this piece, is 2/3 of the whole thing. So 2/3, 1/3. The piece from the vertex is the larger piece. Let's open it up and use it. Example 1. Use the centroid theorem to find the lengths. We are given that AF is equal to 9. So the whole thing is equal to 9. We are given that CE, the whole thing, is equal to 7.2. So we're going to find AG. Here is AG. AG is part of AF. AF is 9, and you have a 2/3 piece and a 1/3 piece. So to find AG, that is the 2/3 piece, so we're going to multiply it by 9. 2/3 by 9. And that means AG is equal to 6. AG is equal to 6, because 2/3 times 9 is 6. So that means this part is 6. This part is 3, because we're cutting 9 into thirds. This one has 2 of them, this one has 1 of them. Okay. B, GE. Here is GE. GE is the smaller part of CE. So this one is 2/3, this one is 1/3. So 1/3 of 7.2. So GE is equal to 2.4. Okay, so they're broken into 2/3 from the vertex, 1/3 to the side. Okay, number 6. Vertex L is 8 units from the centroid. L, M, N, P. Vertex L is 8 units from the centroid. Find the length of the median that has one endpoint at L. That means find the length of this, the whole thing. Let's just make up a letter. Let's say X. Okay. Since L to P is 8, we have to find this remaining piece here. Now, when we had this up here, this is 2/3, this is 1/3. So this is 2/3. If we divide this into 2 congruent pieces, or 2 equal pieces, we would have 4. 8 divided by 2 is 4. That means this piece is 4, because this is 2 pieces of the third, and this is 1 piece of the third. That means this whole length right here is 8 plus 4, which is 12 units, is the answer. Okay. Try number 7, pause it, and then try number 8. Number 7. Let P be the centroid of STU. STU. P. And let SW be a median of STU. That means it's W down here. If SW, the whole thing, is 18, we're supposed to find these pieces, the top piece, the bottom piece. To do that, we're going to take 18 and divide it into 3/3 pieces. That is 6. That means, since this is 2/3, we would have 2 of these 6's, which is 12. So SP is 12. The PW part is just 1 of the thirds, so it is 6. Number 9. In triangle ABC, the median AD is perpendicular to BC. If AD is 21 feet, the whole thing is 21 feet, describe the position of the centroid. Meaning, I want you to tell me how it's in position from A or D. Okay? I need to take that 21 and divide it by 3, and that is 7. That means the centroid, yes, it froze. That means the centroid is 7 units from D, or 14 units from A. You only have to have one answer. You don't have to have the or. You could have this one or this one. You don't have to have both. But it's the idea of the 2/3 part. This part is 1/3, this part is 2/3. Okay? Alright, let's look at 9 and 10. We're actually going to construct them now. Number 9. Find the centroid of the triangles with the given vertices. Show your work and check your answer. We're not going to check, we're just going to look here. Okay, P is -1, 7. That means we're going to have to actually draw a thing first. We're going to have to draw a coordinate plane. Not sure we can go all the way to 7. We'll have to find that out. Yeah, we should be. Do we have negative y's? No. Y'all, I used a straight edge and look at that mess. Okay, -1, 7. 1, 2, 4, 5, 6, 7. Here's P. 9, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Q and R is at 1, 2, 3, 4. 1, 2, 3. R. Okay, the centroid is made by medians. Remember, medians are from the midpoint to the vertex, and we don't have to find all 3. We could just find 2 of the 3 and move on. Okay, so let me try to focus that a little bit better. All right, so centroid is from the median midpoint to the vertex. So let's find the midpoint of RQ. Okay, so R is at 4, 3, and Q is at 9, 5. So the midpoint of RQ is 9 plus 4 over 2, and 5 plus 3 over 2. Remember, it's finding the averages basically. So that is the midpoint of this. So 9 plus 4 is 13, divided by 2, 6.5. 5 plus 3 is 8, divided by 2 is 4. So 6.5, 4. 1, 2, 3, 4, 5, 6.5. 1, 2, 3, 4. Right there. I'm going to draw from P to that midpoint. You got to be as precise as possible, because if you're not going to get the right centroid. Okay, now let's go from a different side. It doesn't matter. Let's say PR or PQ. Doesn't matter either way. I do PQ. P to Q, we have -1 plus 9 divided by 2. 7 plus 5 divided by 2. -1 plus 9 is 8, and divide that by 2 is 4. 7 plus 5 is 12, divided by 2 is 6, so 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh, and you know you've done something wrong if it's not on the segment that you were finding the midpoint of. Okay, and then draw that straight down. Alright, it looks like we have our centroid right here. Where they cross, right, there's the centroid. So the centroid, the answer I'm looking for, is 1, 2, 3, 4. 1, 2, 3, 4, 5. So the centroid is 4, 5. This is an obtuse triangle, and in this obtuse triangle, the centroid was on the inside. We need to remember that. It's on the inside. Just remember, sometimes the locations matter. Let's look at number 10. You could probably pause the video and try to find the centroid yourself. That's the last one we're going to do. Okay, graph this. -6, 1, 2, 3, 4, 5, 6, 0. 0, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A, B, 6, 0, 1, 2, 3, 4, 5, 6. C. Okay, I could connect this, but you know, basically it's... Okay, centroid. Let's find the midpoint. Now I will tell you AC, by the way, the midpoint, since this is 6 and 6, the midpoint's right here on the origin, so I'm not even going to actually calculate it. And then draw it up to B. Okay, there. There's one of them already, so I'm not, you know, there's one of them. So let's find the other one now. Let's find the midpoint of AB. And that is -6 plus 0 over 2. And 0 plus 12 over 2. So the midpoint is -3 and 6. So -3, 6. 1, -2, -3. 1, 2, 3, 4, 5, 6. And draw that to C because it's the opposite. And that should tell us what our centroid is. Centroid is where it crosses. So the centroid is located at 0, 1, 2, 3, 4. Okay. This is an acute triangle, and the centroid was on the inside. Centroid is always inside the triangle. Just like in center was inside, centroid is inside. Say sin, in, or something, I don't know, so you can remember. Circumcenter was not. Alright, we're going to glue this in the notebook on page 68. We'll talk about the last triangle congruence later. Tomorrow, glue this in on 68, and we will talk about that then later.